Welcome to the DIY Honda Garage channel. The diagnostic trouble codes P0202 and P0203 indicate a malfunction in the number 2 and number 3 cylinder injector circuits, respectively, in Honda CRV models from 2017 to 2022. These injector circuits are crucial for fuel delivery to the engine, ensuring proper combustion and performance. Each injector is electrically controlled by the Powertrain Control Module, PCM, which receives signals to open or close based on engine conditions. When an injector circuit fails, it can significantly impact engine performance, causing issues such as misfiring, stalling, or difficulty starting. The injectors are typically located near the fuel rail, mounted on the engine's intake manifold. Understanding these components and their roles is essential for effective troubleshooting of the DTCs. DTC P0220 indicates a malfunction, specifically in the number 2 cylinder injector circuit, whereas DTC P0203 indicates a similar issue for the number 3 cylinder. Each injector circuit's pivotal role is to deliver precise amounts of fuel into the engine's combustion chamber. When these circuits malfunction, the engine may experience performance issues such as hesitation during acceleration or reduced power. The main components involved include the injectors, the wiring harness leading to them, and the PCM, which controls the operation of these injectors. The injectors are generally found mounted directly on the engine's intake manifold, close to the combustion chambers for effective fuel delivery. Diagnosing these circuits requires attention to both electrical and fuel integrity in the complete system. The potential causes for DTCs P0202 and P0203 can vary from a faulty injector to issues within the wiring harness. A faulty injector can prevent it from opening, leading to engine performance problems. Wiring issues could include open circuits, shorts, or damaged connections, which disrupt the signal from the PCM to the injector. Relay malfunctions often stem from corrosion or internal failure and can prevent the injector from receiving the necessary current to operate. Additionally, any blown fuses can interrupt the power needed for the injector circuits. Addressing these issues systematically is necessary to ensure that the circulatory integrity of the fuel delivery system is restored, leading to optimal engine performance. Symptoms associated with DTCs P020 and P0203 often manifest as engine misfires, which can be noticeable when the vehicle is in operation. This misfiring occurs due to an imbalance in fuel delivery to the cylinders, ultimately impacting performance. Difficulty starting the engine is another common symptom, potentially indicating fuel starvation. Drivers may also experience reduced power during acceleration or abnormal idling, signaling an ignition or fuel delivery issue. It's important to observe these symptoms as they can provide valuable insights into the underlying issues affecting the fuel injector circuits. Immediate attention to these symptoms can prevent further damage to the engine components. The first troubleshooting step requires verifying the problem before proceeding any further. Start by turning the vehicle to the on mode to power up the electrical systems. Use the Honda Diagnostic System, HDS, to read the diagnostic trouble codes and clear any existing DTCs. After clearing, turn the vehicle to the off/walk mode and start the engine. If the engine does not start immediately, crank it for about 20 seconds. Subsequently, check the HDS again for any pending or confirmed DTCs. If DTC P0202 or P0203 is present upon rechecking, this confirms a persistent issue. If no DTCs appear, it may suggest an intermittent failure, prompting further investigation into connections and terminals. In this step, the focus is on determining whether the engine can start successfully. try to start the engine, as this will provide insights into the state of the injector circuits. If the engine starts, proceed to step 11 for further diagnostics. However, if the engine fails to start, that indicates a deeper issue, possibly related to the injectors or ignition system. It is important to gather this information for accurate fault isolation. Evaluating the situation helps in understanding if additional electrical system checks are necessary at this point in the troubleshooting process, which will assist in mapping out the next steps effectively. In this step, the goal is to assess the injector relay, which is crucial in the functionality of the injector circuits. First, ensure the vehicle is turned to the off-lock mode before proceeding. Remove the injector relay and perform a test to determine if it is functioning correctly. A functional relay is essential for the injectors to receive the correct signal and power supply. If the relay tests as operational, you can move to the next step in the troubleshooting process. Conversely, if the relay is found to be faulty, replacing it will be necessary before further diagnostic steps are undertaken. This is crucial, as a malfunctioning relay can lead to a complete failure of the injector circuits. This step involves checking for open circuits in the +B IGP line, which supplies power to the injector relay. Begin by ensuring the vehicle is turned to the off-lock mode and that the injector relay is disconnected. Measure the voltage between test points, specifically between injector relay 4P socket terminal number 3 and body ground. If battery voltage is detected at this junction, that indicates the +B IGP wire is intact. If there is no voltage present, it suggests an open condition may exist in the wiring, necessitating further investigation in the next steps. This testing is vital for isolating potential wiring issues that could affect injector performance. In this step, you will check a specific fuse associated with the +B IGP wire, which is crucial for proper operation. Locate and examine fuse number A715A, found in the underhood fuse relay box to determine its condition. If the fuse tests OK, this means there might be an open in the +B IGP wire between the fuse and the injector relay, and you will need to investigate and repair that. If the fuse is blown, repair any shorts found in the wiring before replacing the fuse. This step is critical, as compromised fuses can disrupt electrical flow necessary for the performance of the injector circuits. This step focuses on the +B Inj line, which is another power supply line critical for injector performance. As in previous steps, ensure the vehicle is turned to the off-lock mode with the injector relay disconnected. Measure the voltage between the injector relay 4P socket terminal number 1 and body ground. If adequate battery voltage is present, it confirms that the +B Inj wire is functional. Conversely, a lack of voltage indicates a potential issue in the wiring that must be addressed in subsequent steps. This process reinforces the need for thorough checks of all power lines, ensuring that voltage is reaching the necessary components. At this point, you will examine a fuse critical for the +B Inj line, specifically fuse number A1020A. Located in the underhood fuse relay box, checking this fuse allows you to assess the integrity of the electrical system supplying power to the injectors. If the fuse is operational, you will need to investigate and repair an open in the +B Inj wire between the fuse and the injector relay. If the fuse is blown, first repair any shorts present in the circuit. Then replace the A10 fuse. This step is essential, as both the integrity of the fuse and the associated wiring directly affect injector operation. This step shifts focus to the FI main RLY CL- and any other potential problem areas. Start the vehicle to the on mode and measure the voltage across test points at the injector relay socket terminals. If battery voltage is present, the FI main RLY-CL- wire remains permissible. However, if voltage isn't detected, this indicates an issue that requires further investigation in the next steps. Analyzing these points helps to isolate potential failures in the relay control mechanism affecting the entire operation of the fuel injectors. In this step, you will specifically check the FI main RLY clear line. This requires bringing the vehicle to the off, lock mode, and jumpering the SCS line with the HDS for over a minute to stabilize the system. Disconnect the specific PCM connector and check for continuity between determined test points. Conduct this test with the vehicle off and the relevant connectors disconnected. If continuity is confirmed, this indicates that the FI main RLY clear connector wire is functional, implying the issue lies elsewhere in the system. Conversely, lack of continuity indicates an open that will require repairs to ensure proper operation of the injector circuits. In this step, the focus shifts to the INJ RLY out wire. After setting the vehicle to off, lock mode, use a jumper to connect the designated terminals in the injector relay. Then, measure voltage across specified test points with the PCM connector disconnected. If battery voltage is detected, the INJ RLY out wire is intact. If there's no voltage, this suggests an open wire issue that needs repair. Verifying the integrity of this wire is crucial for proper injector operation, as it relays power from the PCM to the injectors. In this step, you'll confirm the presence of DTC P0202. Evaluating the status of the DTC will help guide further troubleshooting. If P0202 is indicated, continue to step 12 for a more focused examination. If it's not present, this suggests an intermittent fault may have occurred, warranting a review of the injector connections and terminals. It is essential to track confirmed codes to accurately direct the troubleshooting process. This step reinforces the importance of regularly checking and documenting the DTCs throughout the entire diagnostic procedure. This step involves verifying the continuity of the INJH2 and INJL2 lines. Start by turning off the vehicle and reinstalling the injector relay. Jump the SCS line with the HDS beforehand as an added measure to stabilize the system. Disconnect the relevant PCM connector and test for continuity between set test points. This checks whether the circuit paths for both injector lines remain unobstructed and intact. If continuity is confirmed, move on to the subsequent step. If not, repairs will be necessary in the identified circuit. In this diagnostic step, focus on the number 2 injector 2P connector. Disconnect it and test for continuity from the specified test points while having the vehicle turned to off lock mode. This methodology ensures that any faults in the wiring to the number 2 injector can be identified effectively. If continuity is present, you can move forward to check the functionality of the injector itself. However, if there's no continuity, repairs to the INJH2 wire will be required to restore proper function. This step centers around evaluating the continuity of the INJL2 line. As with previous steps, ensure the vehicle is in the off mode and focus on the number 2 injector connector. Measure for continuity between the specified terminals, checking if there is an uninterrupted path between the PCM and the injector circuit. Confirming continuity will affirm the operational state of the INJL2 wire. If the continuity test is successful, the next logical step is to replace the number 2 injector, as it may be malfunctioning and causing the DTC. Now, Let's focus on identifying any short-to-power conditions within the INJH2 wire. To begin the check, disconnect the number 2 injector connector and turn the vehicle to the on mode. Measure voltage at designated test points to determine if any voltage is present in an unintended manner. If voltage reads high, this indicates a short-to-power condition that needs to be repaired immediately. If there's no voltage, move to further tests to explore other possible issues that would affect the injector circuits. In this step, similar checks will be carried out for the INJL2 wire. Disconnect the number 2 injector and ensure the vehicle is powered on to measure the voltage. If voltage shows up where it shouldn't, repairs for the short-to-power within the INJL2 wire need to be addressed. Conversely, if the measurement gives a 0 reading, this suggests that the wire's integrity is preserved. Maintaining proper wiring condition is essential to ensure that the injectors operate correctly, making this measurement a vital diagnostic step. This step aims to identify any short-to-ground conditions in the INJH2 line. Start by turning the vehicle off and checking continuity between designated test points on the disconnected number 2 injector connector. Finding continuity may indicate there's an unwanted grounding issue that needs fixing. If there's no continuity, the line is functioning correctly, and the issues may not stem from the injector wire itself. This exploration assists in narrowing down potential causes of the original DTCs, leading towards an eventual solution. Focusing on the INJL2 line, this step examines for any short-to-ground conditions present within the wiring. As with previous steps, you will check between specified test points using the vehicle in off mode. Should continuity be detected, it suggests unwanted grounding along the wire, demanding an immediate repair to restore functionality. Failure to rectify this may continue to hinder injector performance, perpetuating the issue identified by the DTCs. If continuity is absent, it signals that the line's integrity is being maintained at this stage. This step shifts the attention towards the number 3 injector 2P connector and its wiring. Disconnect the connector and check for continuity as elaborated in the diagnostic instructions. This specific examination targets the INJH3 line, ensuring that integrity is maintained from the PCM to the number 3 injector. Should continuity show successful, proceed with additional diagnostic checks. If continuity is absent, repairs to the INJH3 wire will be necessary to ensure it is not the source of the reported DTC issues. Investigating the open wire conditions for the INJH3 and INJL3 lines, this step requires the vehicle to be in the off mode. Reinstall the injector relay and conduct a stability test before disconnecting the relevant PCM connector for continuity checks. Focus on the specified test points, measuring for continuity to ensure the paths between circuits are free of interruptions. Confirming continuity indicates that both lines are operational, paving the way to possibly explore other underlying issues related to the performance of the injectors. In this diagnostic phase, focus on continuity testing for the INJH3 line by assessing the number 3 injector 2P connector. Following proper disconnection of the wiring, utilize the continuity test to isolate faults. If continuity is confirmed, the wiring to the number 3 injector is intact, directing further exploration elsewhere in the DTC framework. However, lack of continuity suggests the need for repairs in the identified wire, which could be contributing to the ongoing injector circuit issue. Methodical analysis in this step is critical for fault isolation. Focusing on the INJL3 line, the continuity check requires proper isolation from all other connectors, as previously done. After ensuring proper disconnection, continuity tests will validate the operational status of the circuit, leading to the number 3 injector. If continuity is verified, it affirms that the wiring is adequate, and a failing injector could be the next suspect for replacement. If the continuity check fails, repairs will need to be made to restore circuit integrity. Consistent repetition of these checks is integral for clarifying the source of the malfunction. This step focuses on the INJH3 line for possible short-to-power conditions. With the number 3 injector 2P connector disconnected, it's crucial to measure the voltage while the vehicle is powered on. Should voltage be detected where it shouldn't be present, this indicates an immediate need for repair of the short within the wire. On the other hand, if no voltage readings are found, it suggests that the circuit remains uncompromised. This voltage measurement is essential for establishing the electrical integrity required for the injector's function. Continuing with the theme of inspecting wire conditions, this step assesses the INJL3 line for short-to-power issues. It requires measuring voltage while the vehicle remains in the on condition. Detecting voltage signifies a short that needs mending, while an absence indicates that the wiring is likely maintained without fault. This consistency in electrical integrity across both injector circuits is crucial for ensuring optimal engine performance throughout operation. For this step, the emphasis shifts focus to verifying potential ground short conditions in the INJH3 line. Disconnecting the number 3 injector connector is essential for testing continuity between specified terminals while the vehicle is off. Finding continuity in this test would suggest a short-to-ground issue that would require immediate addressing to prevent ongoing injector malfunctions. Conversely, if continuity is absent, it may imply the circuit integrity is solid and the issue could lie elsewhere in the system. This step targets the INJL3 line, checking for possible short-to-ground issues similarly to previous ones conducted. Checking for continuity while the vehicle remains off is essential for determining whether any unwanted grounding conditions exist. Should continuity be identified, it suggests an intervention is necessary to repair the fault, whereas a lack of continuity points towards a healthy line, allowing for exploration of different system areas. The investigative focus here fosters a better understanding of the potential reasons behind the DTCs. Finally, this step addresses the INJH2 line by checking for continuity via the number 2 injector connector. Making sure that the PCM connections are all disconnected while performing the test is critical. Should continuity return a positive result, it implies that the wiring is intact, yet might not resolve the underlying functional issues. However, if there's no continuity detected, repairs will need to be performed on the INJH2 wire to restore its operational status and functionality within this circuit. Each of these steps builds a comprehensive approach to diagnosing and resolving the issue reflected by the DTCs. Once all necessary repairs have been completed for DTCs P0202 and P0203, it's crucial to perform verification to confirm successful resolution. Check that each component, wiring, and connection have been thoroughly evaluated and corrected as needed. Follow this by conducting a test drive to see if the issues persist under normal operating conditions. Upon returning, rescan the system using the Honda Diagnostic System, HDS. For any remaining or new DTCs, successful completion without any codes or symptoms reflects that the repairs were effective. This final verification process serves as a safety net to ensure everything is functioning as it should before finalizing the service. To prevent future occurrences of DTCs P0202 and P0203, implementing a regular maintenance routine is essential. This includes systematically inspecting electrical connections, wiring integrity, and component conditions to ensure everything operates efficiently. Drivers should also be aware of any changes in vehicle performance, as these may indicate underlying issues needing attention. Periodically checking the injector harness for wear or damage can preemptively mitigate against larger problems. Maintaining a clean and dry environment for the engine compartment also helps maintain the reliability of these crucial systems long-term. Recognizing and acting upon these preventive measures contributes significantly to the overall health of the vehicle. In conclusion, DTCs P0220 and P0220 highlight significant issues within the injector circuits of the Honda CRV from 2017 to 2022. Understanding the roles of fuel injectors and their circuits is paramount in diagnosing and resolving these issues effectively. Thorough checks of wiring, connectors, and related components can help isolate the precise cause of the malfunction. Consistent diagnostic processes and preventive measures can aid in maintaining the health of these systems moving forward. By employing a detailed and systematic approach to troubleshooting, vehicle performance can be optimized, and future issues can be mitigated efficiently. Please like and subscribe to the channel. See you next time.